Okay, hi guys. So in this video, we're going to be going over the concept of magnification. So what do you think of when you think of magnification? Well, the magnification is defined as the process of enlarging something's apparent size, but not its actual size. So what does that mean? I'll just write that down. Magnification equals enlarging apparent size, not physical size. Okay, so what does that mean? Well, that basically means that if you were to take an object, magnifying it would make it look like it's bigger, but it's not actually gotten bigger. So let's say we had a circle over here. If I were to magnify it, then it would look like this to me. And if we said that it has a radius of 1 cm, r is equal to 1 cm, the radius of this one would still be 1 cm. It would just look a lot bigger. And it would measure differently if we were to measure it from like a photo or something, but we would know it's still 1 cm just because we're seeing it up closer, for example. So what does that mean when it comes to cells? Well, when it comes to a cell or when it comes to an object, it just means that we need to be able to determine how much has been magnified and work out the equation based on that. So what we want to do is first figure out how can we link the magnification to the drawing size and the actual size. Because if, for example, we take our circles back, let me just get them back. If we take our circles again, let's say that this over here on the photo measured 1 cm. 1 cm. But over here on the photo, this measured 10 cm. So even though the radius has actually stayed the same in reality, it looks like it's 10 cm because it's closer to us. So we can say that it's been magnified by 10 times because the drawing size of 10 cm compared to the actual size of 1 cm, it's been enlarged by 10 times. So from this, we can already start to determine an equation. So thinking, let's link it into one equation. So d is equal to drawing size, let's say. A is equal to actual size, and M is equal to magnification. So drawing size you might see as drawing size you might see as image size. It doesn't really matter. The point is the equation remains the same. So knowing that in that circle, the actual size was, or the actual radius was equal to 1. And the drawing size was equal to 10. And we knew that it had been magnified by 10 times, considering that it was 10 times bigger. So magnification, I'm just writing mag is equal to 10 times. It can be apparent that magnification, it's apparent that magnification is drawing size over actual size. And that's the equation. So M is equal to D over A. And based on this, we can rearrange to find solve for D and A. So we can get D is equal to MA and A is equal to D over M. So in this respect, we've managed to isolate all three variables and we can therefore use them. So let's take a look at this question over here. So let me just move this all out of the way. I'll put this to the side. Okay, so if a Sequoia sempervirens tree is 100 m tall and a drawing of it is 100 millimeters tall, what is the magnification of the drawing? And they've given us some options. Now, first thing to do is we cannot just go and do drawing size over actual size until we've converted it to the right units. So 1 millimeter, we know, as it says here, is equal to 0.1 centimeters. And 1 centimeter is equal to 0.01 meters. So actually I should have written this differently because it's a bit difficult to work with decimals. So let's look at the 100 meters. So 100 meters is equal to, well, it's 10,000 centimeters. And 10,000 centimeters is equal to 100,000 millimeters. That's easier to look at. So now we can solve for the magnification. So we know that magnification is equal to drawing size over actual size if we use this part of the equation over here. And the magnification is therefore equal to the drawing size, which is 100 mm over the actual size of 100,000 mm. So if we just cross out the zeros, so that's 2 zeros gone, that's 2 more zeros. So we're left with 1 over 1,000 times, which is equal to, just put that into our calculator, 0.001 times. So therefore, the answer is A. It's been magnified by 0.001 times. And what that means is that the drawing size has essentially become smaller because magnification refers to enlargement, and in this case, it becomes smaller. So that means that the magnification would be less than 1 times, because 1 times means the size is just the same. So that makes sense. Let's look over one more example of magnification. Okay, so this is another kind of question that you might be asked. So the micrograph shows itself in the root of an onion, which is Allium cepa, during mitosis. And let's say we define the magnification of this cell. So the only information we're given is that this scale bar is 250 micrometers. So micrometers is actually denoted by this fancy looking U, which is actually known as mu, and an M next to it. So 1 micrometer, or rather I'll say 1 millimeter, is equal to 1,000 micrometers. That's the conversion. So it's asking us to find the magnification, but we only have the actual size, which is 250 micrometers. And we don't have the drawing size, so let's just write that down. So actual size is equal to 250 micrometers. Drawing size is equal to, let's call that X since we don't know it yet. And magnification is equal to M. So right now what we have is magnification is equal to drawing size, which is X, over actual size, which is 250. So we can't find the magnification until we know what X is. So we need to find a way to find the drawing size. Well, the good thing is that drawing size is basically what you see on the paper, so you can literally just measure it. The scale bar given here extends all this way across the width of the cell. So you just need to get your ruler and measure that. So step 1, measure scale bar with ruler. Then let's say you get your answer you would usually use look at the millimeters look at the length in millimeters. So afterwards convert to same units. So an important part of magnification is ensuring that all the units are the same. So drawing size and actual size have to be the same units of measurement, so they have to be either all micrometers, all millimeters, all centimeters. It doesn't matter which one as long as they're consistent. The magnification doesn't have either of those. Its units are a times sign, as I had shown in the last one. So convert to the same units. 3, apply values into equation. And in that way, you can solve for the magnification. So actually, I'm on my iPad, so I can't really measure it. However, let's say it happened to be, let's assume length is equal to 10 millimeters. So 10 millimeters is equal to, well, 10 times 1,000 micrometers, which is 10,000 micrometers. So apply values into equation. Well, M is equal to 10,000 over 250, which is equal to 40. So 40 times. So that would be our answer if 10,000 was the right value, which it isn't. You would need to measure it on the paper you get when you're doing your exam. But afterwards, it's very straightforward. You just follow the same process. So hopefully magnification has become a lot easier, and you'll be able to tackle it when you get your exam.